the Swiss Army knife. It is famous for a reason. It is versatile, handy, and gets the job done. That's why we are proud to present Ilum, the Swiss Army knife of data lakehouses that puts you in the driver's seat. In the big data world, you can either cling to ancient tech like hosted Hadoop yarn, or sell your kidney to afford Databricks or AWS EMR. Ilum offers you a third path. Modernize your data stack for the low price of absolutely nothing. Ilum is more than just another tool. It's your command center for Apache Spark jobs, interacting and exploring your data using Jupyter notebooks or SQL queries, tracking your data lineage, and using seamlessly integrated Apache Airflow, MLflow, and more, all through a web interface that is sleek, powerful, and reliable. Best of all, Ilum runs anywhere, on-premise, in the cloud, or on a managed Kubernetes cluster. For the developers, Ilum feels like strapping on a jetpack in a world full of bicycles, allowing you to run your Python or Scala code interactively in a matter of seconds. Ilum bridges the gap between versatile data lakes and reliable data warehouses, with the Data Lakehouse architecture providing a unified view of your data that will make the analytics team weep tears of joy. To get started, you will need two things. A host Kubernetes cluster, a local Minikube for testing is more than enough, and Helm, a package manager for Kubernetes. Start your Minikube cluster with the Minikube start command. Add the Ilum Helm repository and install the Ilum package. After a couple of minutes, check whether all the pods have the running status and expose the port the UI runs on. Now head to Ilum's website and download the example Spark job. Open up the UI, log in with the default credentials, and create a new group. Enter a name of your choice, choose the default cluster, and use the drag and drop functionality to easily provide the downloaded job. Once the Spark container is ready, hit the Execute Job button and enter the canonical name of the job's class. Congratulations! Now you can conquer the world of big data without breaking a sweat. To learn more, head to ilum.cloud and check out the documentation. Claim your free Ilum license and start building your future today.
Okay, folks, that was a brief introduction. Hope it played correctly for you, because on my end it was just flickering every other second. So hope that you managed to see it properly. And yeah, with that being said, being shown, I think that we can get into the presentation part. So let me share my screen, and maybe first of all, let me introduce myself. My name is Stan. I'm going to be a presenter for today, and joining me is Arek, who is going to be the lead expert today. Glad to have you, Arek, because expert is going to be very important today, especially since I wanted to ask everybody to stay after the presentation and the demo, because we're going to have a dedicated Q&A session at the end. But also, let's not try to just sit down and listen like we're on a lecture. If you've got any questions, please feel free to ask them on the chat, and Arek or someone else from our team will respond to your query. So yeah, today's webinar is about Ilum, the free data lakehouse. Yeah, I've already asked you to use the chat to see if it works. We got it going. So if you could just quickly let me know if you can see my screen, see the presentation window, I'll be very happy. Perfect. Thank you very much. Let's get on with it. The agenda for today. We're going to start with a quick introduction to the problems at hand, followed by a quite detailed overview of how Ilum tackles those issues. After all that, you're going to be shown a demo that will show you how Ilum works in real life. And one disclaimer, the demo will be shown on the release candidate version, which will soon be released. And afterwards, after the demo, we're going to have a live Q&A session on which I hope everybody's going to stay, and we'll be able to have some discussion. Okay, with all of that said, let's dive in. Let's begin with talking about the elephant in the room, which is data management in today's digital age. I'm pretty sure we all know that data isn't just numbers and stats anymore. It's the backbone of strategic decision making. But managing endless sets of data across diverse environments, be it cloud, on premises, or hybrid, can feel like juggling while riding a unicycle. I think it's a safe assumption to say that most of you here are working with data on a daily basis, so you know better than anyone else about the chaos that appears when the control over data is lost. Data volumes are constantly growing, and in the era of AI and machine learning, this growth is accelerating. Many companies are focused on implementing AI and machine learning solutions, but often ignore the foundational element that fuels these technologies. And of course, it's the data. But it's not just about AI or machine learning. Even if your organization isn't diving into those topics, the challenges of managing vast amounts of data remains the same. Firstly, as always, the costs are a big problem. Platforms like Databricks and Snowflake offer powerful features, but they can be very expensive. This puts a strain on budgets and limits our ability to invest in other important areas. Secondly, many solutions are focused on the cloud. Not everyone can or even wants to put all their data in a cloud. Some organizations need to keep data on their own servers or use a mix of both cloud and on premises systems. When platforms don't support this flexibility, it leaves these organizations without good options. Thirdly, there's the issue of vendor lock in. This happens when a platform ties you to one provider, making it hard to switch to other tools or technologies in the future. It limits our flexibility and can prevent us from adopting better solutions as our needs change. And next, data silos are a significant challenge. When our data is spread across different systems that don't talk to each other, it's hard to get a complete picture. Integrating this data becomes complicated and slows down our ability to make informed decisions. Because of these issues, the most popular architectural approach in terms of big data, the data lake, of course, often transforms into a data swamp. While data lakes are designed to store large amounts of raw data in its native format, they can become unmanageable without proper governance and structure. These challenges highlight the need for more flexible and cost-effective solutions. We need options that let us avoid being locked in to a single vendor, choose where to deploy our systems, and make it easier to bring all our data together. All right, let's dive into the current state of data architecture. Understanding how data architecture has evolved over time is crucial because it sets the context for why we need platforms like Ilum today. Let's rewind the clock to the good old days of traditional data warehouses. Back then, data was primarily structured and came with a limited number of resources, like transactional databases. We relied on data warehouses to store and manage this data. These warehouses were designed with rigid schemas, meaning we had to define the structure of our data upfront before we could store it. While data warehouses served their purpose at the time, they came with significant limitations. For example, scalability issues arose as data volumes grew, making it expensive and complex to scale these systems. Additionally, the inflexibility of rigid schemas made it difficult to adapt to new data sources or changes in data structure. As organizations started generating more types of data, semi-structured or unstructured data like logs, images, or social media feeds, the limitations of data warehouses became even more apparent. This led to the emergence of data lakes. Now, the data lakes came into the scene as a solution to handle the increasing volume, variety, and velocity of data. They allowed us to store all our data in its raw, unprocessed form, which was a big step forward in terms of flexibility. However, data lakes introduce new challenges. Without proper governance, data lakes can become disorganized and cluttered, a data swamp, making it difficult to find and trust the data you need. Furthermore, since data is stored in its raw form, it may contain errors, duplicates, or inconsistencies, leading to a lack of data quality and consistency. Additionally, querying large volumes of raw data can be slow and resource-intensive, resulting in performance issues. Many of you might have experienced these issues firsthand, the initial excitement of setting up a data lake, only to find it becomes a data swamp over time. So how do we address the shortcomings of both data warehouses and data lakes? The answer lies in the emerging data lakehouse architecture. This new approach aims to combine the best of both worlds, the reliability and performance of data warehouses with the scalability and flexibility of data lakes. By transforming our data architecture in this way, we can better meet the demands of today's data-driven world. Platforms like Ilum are designed to leverage this new architecture, helping us manage and analyze data more effectively. Think of a data lakehouse as the best of both worlds. We get the scalability and lower cost of a data lake, combined with the strong data management features you'd expect from a data warehouse. This setup lets our data teams run analytics on both structured and unstructured data all in one place. Basically, it's a unified platform that supports all types of data workloads, batch processing, real-time analytics, machine learning, and more, without the inefficiencies and complexities of traditional data architectures. The Data Lakehouse maintains consistent data formats for quality assurance while still allowing us the flexibility to adapt to changes over time. This means we can enforce schemas when needed, but also evolve them as our data requirements change. Now, let me cover the key parts that make it powerful. Compute engines like Apache Spark for processing data, tools like Jupyter and MLflow for analysis and machine learning, open table formats like Data Lake for data reliability, scalable storage systems like Amazon S3 to hold all your data, and a flexible environment like Kubernetes for easy deployment and management. By bringing these components together, the Data Lakehouse gives you a unified, scalable platform that combines the best of data lakes and data warehouses. We're finally getting to the fun part, don't worry. Let me introduce Ilum, our free data lakehouse solution that's going to make your data management a whole lot easier. So, what's Ilum all about? Well, Ilum is your all-in-one platform for data lineage, data exploration, and data governance. And guess what? It's completely free and super easy to install. We've designed Ilum to be as accessible as possible. Whether you're a massive enterprise dealing with petabytes of data daily, or a smaller team working with just a few gigabytes, Ilum scales to fit your needs. We've worked across the spectrum, and we're confident in saying that it works in all cases. Ilum has come a long way. It started as a tool focused on managing Apache Spark clustered on Kubernetes, but it has transformed into a full-fledged data lakehouse platform. This transformation was driven by the need to harmonize the flexibility of data lakes with the management capabilities of data warehouses. Now, you might be wondering, why is Kubernetes the perfect platform for Ilum? Kubernetes provides the ideal environment because it offers scalability, high availability, and simplified management. It allows you to efficiently manage multiple Spark clusters from a single centralized location, whether they're deployed in the cloud, on-premises, or in a hybrid setup. Kubernetes automates deployment, scaling, and operations, making it easier to handle the dynamic needs of modern data workloads. Many of us are transitioning from legacy systems to more flexible and scalable environments. Ilum has become a widely chosen replacement for Cloudera, particularly for migrating from Hadoop Yarn to Kubernetes-based architectures. This shift enables businesses to leverage the inherent scalability and efficiency of Kubernetes, streamlining their data operations. Additionally, Ilum serves as a formidable alternative to Databricks, especially for companies seeking robust on-premises solutions without compromising the ability to operate in the cloud. This flexibility ensures that Ilum meets diverse operational needs and deployment scenarios. A key aspect of Ilum's strength lies in its deep integration with open source ecosystems. Our platform supports a variety of open table formats such as Delta, Iceberg, and Hoodie, enabling seamless integration across different storage solutions, including S3, Azure, Blob, GCS, and HDFS. This inclusivity extends tools commonly used in data workflows, ensuring that users have a comprehensive set of resources at their disposal. In essence, Ilum not only facilitates a smooth transition from traditional platforms like Cloudera, but also provides a versatile and powerful platform that rivals leading solutions like Databricks, all while maintaining a commitment to open source integration and support. One of the standout features of Ilum is how it dramatically simplifies and enhances your Spark experience. Typically, even for Spark jobs that only take milliseconds to execute, the initialization of the Spark session can delay start times by 15 to 40 seconds. It's frustrating waiting around for something that should be instantaneous, right? Well, Ilum tackles this issue head-on with long-lived interactive Spark sessions. These sessions are initialized just once and can be managed anytime via our REST API or user interface. That means no more waiting for sessions to start every time you run a job. Your sessions are always ready when you are. Setting up your data lakehouse with Ilum is also simplified. You can deploy a Spark cluster within minutes. Pardon me, I think I reshared the wrong screen. Yeah, it's also simplified. You can deploy a Spark cluster within minutes using a pre-configured setup that requires no additional configuration on your part. It's practically plug and play. But we understand that one size doesn't fit all, so if you need a more customized setup, Ilum has you covered. You can tailor configurations to integrate with external storage systems, use custom Spark versions, or include specific Spark packages to meet the unique demands of your applications. This flexibility assures that Ilum fits seamlessly into your existing workflows. And that's not all. Ilum integrates a variety of open source tools directly into the platform. This enhances functionality and the overall user experience without the typical complexity that comes with such integrations, so we get more power and flexibility without the headaches. All right, let's dive into how Ilum isn't just a platform. It's an ecosystem that adapts to your needs and makes your life easier. At Ilum, we believe in flexibility and integration. You're not just using a static tool. You're engaging with a system designed to work seamlessly with your existing tools and workflows. One of the key aspects of this is our API, which is fully compliant with the Open API specification. But what does it mean for you? It means you can integrate your tools effortlessly. You can even generate API source code in your preferred programming language, making the integration process smooth and straightforward. Now let's talk about our interactive sessions. These aren't just your ordinary Spark sessions. We've designed them to eliminate the long initialization times typically associated with Spark, so no more waiting around, you can get straight to work. Whether you're interacting through our API or our user interface, your requests are processed by the Ilum core. This microservice is the heart of our operation. It's deployed within your Kubernetes environment as a scalable pod. This setup ensures high availability and responsiveness, which is crucial for handling real-time data processing efficiently. We understand that different setups have different needs. That's why we offer options when it comes to communication protocols. For smaller setups, gRPC is ideal. It offers simplicity and speed, making it perfect for lightweight environments. For larger environments, we recommend Kafka. It's known for its robustness and scalability, ensuring reliable communication even as your data loads grow. There's also a feature we're particularly excited about. Our interactive sessions come with a pausing capability. When there are no incoming requests, these sessions can scale down to zero, effectively pausing to save resources. But don't worry, once a new request comes in, they spring back to life automatically. This dynamic scaling ensures you're not consuming unnecessary resources during idle times, optimizing both cost and efficiency. This means your Spark job effectively becomes a microservice with an API, ready to respond to your calls at any moment. With built-in load balancing, these sessions can handle requests from multiple users simultaneously, distributing workloads evenly to maintain optimal performance. And here is the real game changer. Our interactive Spark sessions are always ready to execute your commands instantaneously. Thanks to the pausing feature, they can scale down when idle and instantly scale up when needed, providing the best of both worlds, immediate responsiveness and resource efficiency. So, what does this mean to you? Firstly, you get instant responsiveness. Your commands are executed immediately without the long startup times that are often associated with Spark, right? Secondly, you achieve resource optimization. The pausing feature ensures resources aren't wasted during idle periods. Thirdly, you benefit from scalable performance, handling multiple users and heavy workloads. And finally, you enjoy seamless integration. You can use our API to incorporate Ilum into your existing tools and workflows with ease. So, with Ilum, you're not just getting a platform, you're engaging with an adaptive ecosystem that's designed to grow and evolve with you. All right, and now let's get into how Ilum empowers you to handle and explore your data. At the core of Ilum's computing capabilities is Apache Spark. Spark is our workhorse for big data processing. It's fast, reliable, and widely used. But we don't want to limit you to just one engine. We're thinking ahead, and our vision extends beyond Spark. We plan to integrate other computational engines like Apache Flink. Mikhail, you asked about it on the chat. There you go. And Trino to enrich our platform. This means you'll have more choices and flexibility in how you process and analyze your data. One feature we're particularly excited about is our support for interactive groups in the compute layer. These groups let you interact with your data in real time. Imagine being able to run queries, test out transformations, and see results immediately. It's a great complement to submitting standard Spark jobs through Spark Submit, our API, or UI. Now, when it comes to data management, we know that consistency is the key. That's why Ilum offers seamless integration with the Hive Metastore, or the support for Unity catalog just around the corner. This simplifies your data management by eliminating the need for additional configuration and ensures consistent data definitions across the platform. Basically, your schemas and metadata are managed centrally, making everyone's life easier. Let's move on to the data exploration. We understand that being able to query your data using familiar tools is crucial. Ilum fully supports SQL, so you can use standard SQL queries to explore your data sets. Whether you're writing complex analytical queries or just fetching some records, you can do it all without having to learn new languages or tools or some DSLs. But exploring data isn't just about running queries. It's also about understanding where your data comes from and how it's transformed over time. That's where data lineage comes into play. Ilum provides built-in data lineage capabilities, allowing you to track the flow of data from source to destination. You can see how data is transformed, what processes it goes through, and ensure that everything is documented and auditable. This is incredibly useful for compliance, debugging, and building trust in your data. Security is, of course, a top priority for us. That's why I incorporate OAuth 2.0 and LDAP for authentication, complemented by Kerberos and Apache Ranger for authentication and fine-grained access control. This integrated security framework ensures that safeguarding data and platform access remains a top priority. You can rest easy knowing that your data is protected at every level. To keep everything running smoothly, each component within our ecosystem is designed to expose metrics in a Prometheus format, which is supported by a specialized Grafana dashboard for real-time monitoring. This setup helps you track and optimize the performance of your Spark jobs and other processes, ensuring operational efficiency and reliability. You have visibility into system performance, resource utilization, and can quickly identify and address any issues. Ilum's architecture is inherently modular. We've integrated modules that enhance data handling capabilities, including open source tools that are crucial for data extraction, transformation, analytics, and visualization. But we also know that you might have your own favorite tools. That's why Ilum supports the integration of your preferred tools like Jupyter Notebooks and Apache Airflow. This empowers your teams with the resources they need, all on a unified platform. So, to wrap it up, Ilum offers a powerful and flexible platform for your data needs. With robust computing capabilities, real-time data exploration, comprehensive data lineage tracking, strong SQL support, and a focus on security and monitoring, we're confident that Ilum can meet and exceed your data management expectations. Plus, it's free and easy to install, whether you're dealing with petabytes of data or just a few gigabytes. All right, everyone. It's time for the demo. You can still post your questions in the chat. They'll be answered as they are right now. So that's great. Thanks to the Ilum team. Now let's jump into the demo and see how Ilum can transform your data management experience. For that, we're going to show you a video. Sorry for that, demo master unfortunately got sick, and the last thing he could do before passing out in the bed was recording this video for you. So hope you enjoy this, and let's see that.
Let me quickly share my screen. Hopefully you see it. So, hi everyone, and welcome to this quick demo where I will do my best to show you the main features of Loom. This is our main screen where you can monitor what is happening within the platform. And as we see, we have a small cluster of 300 gigs of RAM. Let's start from the cluster view. With every installation, Ilum automatically creates a default pre-configured cluster, the same one on which Ilum was deployed. You can, of course, edit this to amend the configuration or add a new cluster. By adding new cluster, we have few options to choose. The most important one is the type of the cluster. Local one, which is mostly used for testing and debugging, Kubernetes, which is our preferred type of cluster, and Ilum, old good AWP cluster, which we mostly use for migration purposes. But we have many users who have choose Ilum to manage the Spark cluster on the on, which we're completely fine with. The best part is that you can choose your Spark version. Ilum comes with a few certified Spark versions, but nothing is stopping you from entering your own version here. So if you have already built Spark image, or you want to use some official one from Docker Hub or anything else, then nothing is stopping you. We can put some standard Spark configuration, but most importantly, we can add multiple different storage types to one cluster. This means that you or your team doesn't need to remember the credential to S3, the complex HDFS config, which is mostly held within XML files. Instead, your admin can configure it once, and from this point, you will get an access to it from your Spark job because Ilum will inject the configuration for you. Let's back to the cluster view. You can create multiple clusters on the same environment, like the same Kubernetes cluster, and choose a different Spark version or a different configuration for testing or debugging your apps. Moving to the job view. Here we can see all the jobs within the system. We can monitor them by, for example, checking simple metrics, looking into the timeline, checking the executive stats, or going through the logs. In addition to that, we have an access to Spark History Server for in-depth knowledge on what is happening within this job, for example. And now something very important, our interactive Spark sessions, aka Spark microservices. I will present it on two examples. We have created a very simple LLM RAG use case. We will ask a question to the LLM together with providing a context. So we have closed our Spark code within an interactive group, which means that this group has automatically exposed an API and we can scale it up and down to distribute the load. Let's try to interact with it. First, I need to specify the name of the class. And in this example, I have chosen a Spark job written in Python. And here's my requests. I have specified a few parameters. All of them were defined in my Spark code. The first one is the query for my LLM. I'm also specifying the context for it by providing few sources, and I'm using a vector database on internal S3 object storage. So let's change the question. So, for example, describe Ilum architecture. So how does it work? It's just a standard Spark job, standard Spark code written in Scala or Python, closed within a Python file or a jar file. Yeah, so the answer is here. And funny thing is that from this point, we can check the request which was sent to this group. So here is my configuration with my question, and here is the result. And now we can create a very similar, a little bit simpler group. The creation process is very simple. We need to specify things like name, choose the cluster, we can put a description over it, and of course specify how many instances of this will be started from the start, let's say. And here is the very important feature, the auto parse feature. So if there are no requests to this group, it will be scaled to 0. Here we can put some configuration, add the resources as our tar files with my Spark code, my Python files, some additional resources, or even I can put here some additional libraries, Python packages like NumPy or anything else, and those packages will be installed before before starting the Spark job. So it will become available for the Spark to be used within my, for example, Python code. The next thing I can specify, of course, the memory settings and put some extra stuff like dynamic allocation, which will automatically scale my executors based on the load. So going back to general, I will create a code group with Scala language. So with such a simple group, I don't need to put any additional configuration to it except of the name and the type of code. So interactive example, submit. So my group is being started. We can track the progress on the logs. Yeah, it's slowly starting up. Another executors should be it's here, so it will be up and running just in a sec. So let's play with the code. I can run something as silly as this. Of course, it's only for testing and debugging purposes. No one will run such Spark code because it's just too silly. But definitely they will run something like that because this is just a standard Spark code. And the best thing, this is also available through the API, so you don't need to play with our UI to debug something and use the whole power of your resources that you have specified on this cluster, on this particular group, but you can just play it through the API or the UI. So let me put here something more interesting. So I have created a very simple data set, dummy data set. From it, I have created a temporary table. Then I have created a real table. Save this data set to real table. I have added a few, like one column. Then from whole set, I have created another table. And with this another table, I have added another column. Yeah, but the best part, and like really fun part here. I have launched some SQL statements. So let's see that thing from a data lineage perspective. Yeah, here it is. So even based on those simple SQL statements, I'm able to trunk the data lineage of my data, right? Of my SQL statements. So here I have even an access to data history, table history. I know who was playing with my data and when. The same view is available here from the Table Explorer. Where is my table? Yes, it's here. So yeah, this same stuff here. But let's play with something more interesting. So here I have some transactional data. Those are simple table with a very simple schema. I can track the data lineage of this table. So I did some computation over it. Nothing too complex, but still. But from this point, I see that this table was created from this particular file. And I can, of course, check when and who has created it. Here I have a table saved in Delta format. And in the same way, I can check its data lineage with the whole history of who, when, and why was playing with my table. And the best part is that from the same view, I can explore my data. I can check the data distribution, and immediately after, I can play with data to create some visualizations. So let's create one. Let's choose amount, transaction type. Let's count here, location, and maybe choose a color. Yeah, merchant should be great. Yeah, so we have created a very simple chart showing what is within our data from the same view in the Data Explorer part. Yeah, let's jump into File Explorer. Here we have a File Explorer to check what is within our object storage configured within the cluster. So in this case, some Parquet files with Delta logs. Another part is SQL editor, where I can build queries and play with my data with the use of Delta, Iceberg, or Hoodie dialect. I can check some less or more complex queries like that. But let's check the crime data from Los Angeles. So the same view, the data distribution all over this crime table, and the visualization part. So maybe, let's put some data on the map. So I have latitude, longitude, and maybe what to put here? Yeah, area name as a color. Yeah, and that's it. Again, with some few clicks and the use of SQL, we were able to make simple chart. And another part is that here we will be having additional computation engines like Snowflake and HiveSQL later on. Moving to modules, I would like to show you the superset, which is widely used BI tool. Here I have prepared a dashboard with financial transactions from the same table that we have seen before. And all of this data is taken from our platform through SQL connection to Ilum. So let's apply some filtering. So again, the platform is queried for this data. And here we have configured connection to Ilum SQL through Hive connector in Superset. We support many different modules. Not every is available, but we are working to add more and more modules over time. And maybe, yeah, Jupyter might be very good to show because it's also widely used alternative or even main open source notebook solution. Sometime before we included Apache Zeppelin, but I think that Zeppelin is already deprecated and not really used anymore. So let's jump into notebooks. Yeah. So Ilum comes with Jupyter notebooks, and here we have few pre-configured notebooks, which will help you on how to use the platform. So the best part is that you are using the whole cluster. It's not some local instance, not really. You are using the whole power of your cluster. You can of course limit it by specifying how many driver memory or CPU you want to use, but still, if you are clever enough, you can even use the whole 300 gigs. And that's the best far part, because those Jupyter notebooks are automatically configured and set up with the cluster, which means that you have access to all whole tables. You can play with them and even make some pie charts from it. Yeah. Maybe a little bit about this. So in this folder, we have prepared 3 notebooks showing how to play with a medallion architecture. So going from bronze to silver to gold in the end. So basically, it shows how to use a build in Delta to make this move. But of course, you can also use Iceberg or Hoodie with some additional configuration to it. And the last thing, which I have forgot about, are schedules. So we can schedule our job by specifying the timing. The rest looks the same as in job creation. Now, here we have an example of the schedule. So the job is running every 3 minutes. In this case, it's generating some test data and it sends it to Kafka. Yeah, so maybe let's check the processing job. So here is the sorry. Here is the Spark streaming job, which is taking data from Kafka and saving the results into the Delta tables in the form of some KPIs, which then we can create dashboards from with the use of superset or play it through the SQL part. Yeah. You can check our documentation to play with some use cases by yourself. So, for example, here we have the example used on today's demo. So you can grab it, start playing with the data, and by just copying and pasting the stuff, and he will get very similar results as mine. Yep, I think that's all. So thank you. That's the end of our demo. I think that we can start with the QA session just in a minute. Thank you all.